Welcome everyone, myself Ria from CSC Data Science Department. Today I will be giving a presentation on basic ARM instructions. So the first instruction, which stands for load multiple immediate addresses. The purpose of this instruction is used to load multiple registers from the memory and increment the base address after each access. Field protection. It is commonly used to save and restore registers during functional call. It allows you to efficiently store multiple registers onto the stack and later retrieve them. Data copying. It can be used for copying data between memory and registers. Finally, parameter transfer. When calling subroutines, this instruction can load parameters from memory into registers. Okay, now let's look into the syntax. First, which specifies the addressing mode. For example, IA for increment after or DB for decrement before, followed by an optional condition code. Then RN, which is the base register, the register on which the memory addresses are based. Next, followed by an exclamatory mark, which is an optional write-back suffix, which updates the base register after the operation. Next, which specifies the list of registers to load from the memory. Finally, is another optional suffix which indicates the user mode register. Now, let's go through the few advantages of these instructions, which is efficient loading on multiple registers. This instruction allows you to load multiple registers from memory in a single instructions. It is particularly used when the user need to restore several registers after a function call. The second advantage is increment after loading. The instruction increments the base address after each register is loaded. The third advantage is compact code. Using this instruction reduces the number of instructions that need to be loaded into the multiple registers. Fourth is stack operation. This instruction is commonly used for stack operation during the function call. Let's go through a few disadvantages of this instruction. First is register range. This instruction allows you to load multiple registers from memory, but the range registers you can load is limited. Write-back suffix. When using this instruction, the write-back suffix must always be used unless the instructions in an LDM where the register list also contains the base registers. In that case, the write-back suffix must not be used. Write-back refers to updating the base registers with the address after the load operation. The third disadvantage is alignment. The value in the register specified by the base register must be word aligned. This means that the address should be divisible by 4. If it's not aligned, you may encounter unexpected behavior. Now, let's go through the second ARM instruction, that is store multiple increment after. The purpose of this instruction is used to store the word values in the specified register to memory addresses based on the base address. The registers are stored in ascending order, starting from the lowest number to the highest memory address. Exclamatory modifier is used. The instruction write backs the address just above the last stored location to the base register. This instruction is used to store multiple immediate addresses from the registers to memory. Let's look into the syntax. C, which stands for condition code, then followed by base register, then an exclamatory mark, which is enclosed within curly braces, which is an optional modifier that writes back the addresses just above the last stored location to the base register. Then registers a list of one or more registers to be stored, which are separated by commas and surrounded by curly braces. Advantages of these instructions are efficient stack operation. This instruction is commonly used for stack operations such as pushing multiple registers onto the stack. It allows you to store a range of registers in memory with a single instruction. The second advantage is contiguous memory storage. The consecutive memory locations start at the specified base address and continue in ascending order. Registers are stored with the lowest numbered register at the lowest memory address, and subsequent registers follow in adjacent memory locations. The third advantage is optional write back. You can optionally write back the address just above the last stored memory location to the base register. The fourth advantage is variance and syntax. This instruction has different variants with varying encoding formats. This syntax includes specifying the base address, the list of registers to store, and an optional write back flag. Now, let's deal with some disadvantages of this instruction. Caching effect. If the base register is not aligned on cache line boundary, you might incur an extra cache line read from RAM. The second disadvantage is alignment and timing. Incur that the alignment of writes and reads is consistent. When timing the transfer, consider whether you are measuring the entire transfer or individual instructions. Verify that the compiler hasn't changed the position of your time sampling. Finally, the third disadvantage is write versus read speed. The ARM can maintain memory using this instruction about 6 times faster than it can read from main memory using load multiple immediate address. While writes are generally expected to be faster than reads due to caching effect, a 6 times difference seems unusual. Few examples of these instructions are LDMIA, then register R0 followed by an exclamatory mark, then comma, R1, R2, and R3, which are enclosed within the curly braces. Example for the second instruction is STMIA, then register R4 followed by an exclamatory mark, then a comma, R5, R6, and R7, which are again enclosed within curly braces. Best practices for these instructions are plain register to avoid conflicts. Optimize the order of loading, storing addresses for efficiency. Test the functionality thoroughly to ensure correct data transfer. Finally, the conclusion. These instructions are essential for efficient data transfer in microcontroller programming. Understanding the syntax and usage is crucial for optimizing memory access. By utilizing these instructions efficiently, developers can enhance the performance of embedded systems. That's all with my presentation. Do like, share, and subscribe.